So the debate over whether or not the teacher you take matters has always been something important in education. So we're going to look at an example of how we can prove whether or not a teacher is actually making an impact or not. So go ahead, pause the video, make sure you read through it. And now let's go ahead and talk about whether or not we know what we're doing. So first step here is to realize we want to do a hypothesis test. I want to do a hypothesis test if I want to conclude something. And so in this last line here, I want to conclude something, it's got to be a hypothesis test. Next thing I need to realize is that it's a proportion. So I see in here that I have 15 of 54 students. So right there. And then also 58.7%. So in two ways here, this is reinforcing I've got to do a proportion. So I've got a proportion hypothesis test, which means in the first step, I know exactly what I'm going to list. I need to list p hat, I need to list n, and I need to list my student value p naught. Now in this case, p hat is the percentage of her students who scored a 3 or higher, which will be 15 out of 54, or 0.2778 when we round to 4 places. I know she had 54 students, so that's n, and in p naught's what I'm comparing it to. And so I'm comparing her results to AP students overall, which is going to be 0.587. So right off the bat, we notice, yeah, it does look like she's quite a bit lower. Okay, step 2 is our hypothesis. We have our null, which is what we're assuming. We're assuming, yeah, maybe these 54 students didn't do so hot, but overall, if we looked at all of our students, it'd actually be exactly 0.587. So notice I've put p naught here, because I'm assuming that once again, if we looked at all our students, it would line up. HA is what I'm trying to prove. I'm going to compare her to overall students, and I'm trying to show that she is resulting in significantly worse scores. So if she has significantly worse scores, there are probably fewer of her students than in overall AP statistics courses. So I'm putting a less than there. Once again, that's because it's significantly worse, worse being fewer students passing it. Okay, step 3 is my test statistic. When I do my test statistic, the first thing I always calculate is SE. SE is going to be square root, and remember, for hypothesis testing, we use p naught. So it's p naught and 1 minus p naught all over n. When I plug this in then, I'll have 0.587, 1 minus that, all divided by 54. And I encourage you once again to simplify that subtraction before you plug it in. You should be getting about 0.0670 when we round it to 4 places. Notice this SE is a lot higher than the first example we did, and that's because our sample size is a lot lower. So if we're taking low sample sizes, we're going to have more variation between the samples we take. Aside from SE, the other thing I need to calculate is Z. Z is always my observed value, which in this case is p hat, minus my assumed or expected value, p naught, divided by my estimate of the standard deviation, SE. In this case, my Z-score is going to be negative 4.61. Make sure you understand why this is negative, and that's because p hat is less than what I would expect it to be. She's under expectation. Step 4, we go ahead and we start talking about our p-value. In order to get the p-value, we start by drawing a bell curve. I put my z-score on there. Z of negative 4.61 would be below the center, because it's negative, and I shade it. I shade it depending on our alternative hypothesis, which is less than, so I'm going to shade below. We need to go ahead and take a look at our z-table, so let me copy it in here. And the thing we should notice is that when we go to look for our z-score on the table here, it's not even on there. That is, the smallest number I can possibly find here is negative 3.4, and negative 4.6 is even further out than that. Remember, if my z-score is off the table, it means my probability is even smaller than the smallest probability on here, which means my p-value is going to be less than 0.0002, and that's because it's so far down that's smaller than the smallest number on here. Okay, so now that we've dealt with our z-table, let's go ahead and get rid of it. And knowing that our p-value is less than 0.0002, we go into our final step, which is our conclusion. In our conclusion step, we always compare our p-value to our significance level, which is 0.05. In this case, I want you to notice that I know my p-value is less than 0.0002. Well, if my p-value is less than 0.0002, it's definitely less than 0.05. So I have p-value less than 0.05. Anytime my chances are less than 5%, that means I've got enough evidence. I'm going to go ahead and reject H0. When I reject H0, I say there is enough evidence to suggest that, yeah, in fact, it does look like her teaching results or is associated with worse scores. And this is really important how I said this here. It is super questionable to say it's resulting in worse scores. It might turn out that this teacher is teaching at a school that provides less resources or has students who maybe been washed back a couple years. So even though we're saying, well, there's enough evidence to say there's a difference, we can't actually blame it on her. So getting rid of the results in is associated with is a way better way to phrase this.